Hey folks, and welcome back. Again, another look at the little Peter Pan radio from 1933 to 1934 or 5, we'll say. A day of recapping here, so we've got all the new caps, new resistors in, with the exception of the 1 power resistor here. And again, I repurposed these .047s close enough to the .05 that was called out on the schematic. So we're about ready here to get the speaker back in, get the field coil output transformer connections, and get the power transformer back in place. Before I do that, one of my great subscribers and follows my channel, Mattio, pointed out that I made a mistake, or it appeared to, for the RF coils on the top and the one here on the bottom. When I was reading the DC resistance on the output side, I think I had stated 60 ohms, and he noticed it was 60K for both. I went back and did some additional documentation, again, what I think to be the secondaries based on my hand drawing now and tracing everything out, and you can see that DC resistance is much lower, around 5 ohms. But underneath that, it's probably hard to see, but you'll see I also did some inductance readings. But what I want to do, I want to go ahead and take time. I'm going to take the RF coils out of the chassis and do a closer look at those, and just document those for my reference and others in the future. So we'll do the DC resistance as well as looking at the inductance. And of course the inductance is the most important, because the inductance and the capacitance, of course, will allow the radio to tune to the broadcast band. So let's get started. Okay, I've already got this connection loose. I had taken it loose, I think, yesterday. And I'm going to go ahead and desolder this ground connection here. And again, the other connection points are already loose. Now this other wire that you see looping down through the chassis right here, that comes off the, I think the top side of the coil is what I'm guessing. The secondary side, that is, it comes through this eyelet right here in the tube socket. And again, this was part of that gimmick capacitor. So we'll see if we can figure out what that's all about as well. So I'm going to go ahead and just untwist it here, pull this through. Let me get the soldering iron heated up here. And let's get this coil out here. And again, we'll just look at it closer here on the bench. Alright, I had to pull out the big gun to get this loose here. And then when we get ready to reattach this, I'm going to just kind of clean up this glob here and see if I can make that a little better. But again, here's the first RF coil. For those new in the hobby, you can see I got things highlighted here, with the primary side of the coil being here and the secondary here. So let's see if we can figure out the connection point. So again, if you just look at the schematic itself, you would assume 2 connection points for the primary, and then for the secondary 1, 2, but also this third tap location as well. So let's see how many connection points we have on the transformer that are being used today. So again, 1, 2, 3, 4. Let's see if there's 5. Alright, we got the 1 here, 2, ground, 3, 4, 5. But again, these are tied to the same point. So let's see if we can figure this thing out. Okay, others may do it a different way, but I always like looking at the coil from the bottom side. So all I'm going to do is draw this out. So let me continue to do this, and then we'll come back and we'll just take my resistance readings, and we'll just start going between these different points on the coil and document those resistance readings, and see if we can figure out how the connectivity itself works, and again, what should be primary and what should be secondary. And then we'll look at the inductance. Alright guys, about time for a new pencil. I think I'm going to use every bit of this one. and you can see the erasers used up, but we'll keep going with it here. Anyway, you can see the coil, and I've got it here matching again with this mounting tab here facing in the 6 o'clock position. And some of these lines, again, I can already identify by the way the coil was hooked up to the radio and what should be what. So again, just looking at it, and I'll set this down just for a moment. This would be our primary here, or should be, because again that was our antenna connection point, and everything tied to R1. And then you can see this section here went to the what I'm thinking to be the gimmick that ties the two coils together with some capacitance underneath. There was no connection point here externally, but there is a winding that comes back up in here to the coil itself, and it runs back across and ties to the ground. And then these two connection points here, again, they come off the same tap location here. One goes to the type 58 again, which is the RF amplifier, to the grid, one, and the other side goes to one side of the tuning condenser, which I have indicated here. So let's go ahead and start here on the primary side. We'll hook up here at this lead, and let's just do some DC measurements, looking at resistance here from this point to all the remaining connection points to see what we get. Before we do, a little sip of coffee here. Alright, again you can see I've got one lead of the meter hooked up here to what we know to be the primary side, one side of the primary that's going to the antenna, again assuming this thing was wired in correctly. So we'll just go clockwise and see what we get. We'll go to this gimmick connection point first. Let's see if we can get this on here. So you can see I'm reading, what, 5.6 ohms. Let me notate that. We'll call it 5.5. Alright, let's move to the ground connection. And you can see we've got 1.8. Alright, and we'll go to the next location again, which will be here. Alright, tell you what I'm going to do. Let me use the grid cap wire here. That's probably just a little cleaner. And you can see I'm reading, what, 6.9 ohms. Does that make any sense? Let's look at the schematic again. Okay, I'll leave this hooked up here where we left off, but again, you can see on the primary connection here that we do have resistance back to all these other locations. So again, if you look real close here at the schematic, you'll see why. Again, the primary here comes down, and you can see the connection points. So the primary and the secondary are tied together. So let's see if we can figure out what segment is what. And we should be able to do that just by looking at the DC resistance measurements we just made. Again, assuming this other connection point that we're using is correct here for the antenna lead. If we come through this coil, of course we'll have a certain amount of DC resistance. When we get to this point in the coil, because remember the tuning condenser is not in the circuit right now, so we just got to be focused back on this direction. Let's see if we can find the location that has the least amount of DC resistance before we go through the secondary of the coil. So let's look back down here and see what we've got. So we read between this point, 5.5 ohms between the primary winding here, 1.8, and then 6.9. So it appears that it would be this ground connection again, which ties back to a winding here on the transformer on the outside. Let's see if that makes any sense. And I think it does, and here's why. Because again, look at your winding here on the primary side, and again I said it comes back across here and back up into the secondary, but you'll notice it's also a ground location as well. Just follow it straight down. So I think again between this point and this point will be the true primary. So let me hook up again here on the meter. Let's read between these 2 points one more time, and then we'll check the inductance between those 2 points. Alright, just verifying again, 1.8 before, 1.9. You can see it bounce back and forth, no big deal there. So let's get the LCR meter now hooked up between these 2 points. And we'll just document the inductance here, L, between this point and this point. Interesting. In the auto mode, the unit sees this as a capacitor. So you can see the capacitance between the windings here at 4.1 picofarad. Let me notate that. Then let's take this thing out of the auto mode, put it in the manual mode, and see if we can actually read the inductance here on the primary side. I threw this in the manual mode, and again I can't get any usable data, and that makes sense. Again, very little wire used on the primary side, and you can tell that again by the DC resistance of less than 2 ohms. So it's really more of a capacitance value here on the primary, best I can tell. So let me flip this back on again. I'm going to just go ahead and notate the capacitance value across this part of the circuit, just so we'll have it for reference. And let's move along now and see if we can identify the secondary. Okay, so what I should be able to do now, and again I'll change this documentation here. I had 2, so that may be fairly close, and again I'll erase my microhenry reading here that I had, since I couldn't get anything but a capacitance value here on the input side of the coil. But again, if the secondary indeed does attach here to ground, I'm going to just read from ground connection back up to my grid cap connection point, and that should be the secondary part of the winding here. So let's see what we read. And when I redid this, I had 5.1 ohms, and again that was in circuit, and about 216 microhenries. So we'll do the DC resistance reading first, and then we'll put the LCR meter between those points and see what we read. So I've already got the ground connection on. Get my meter turned on. Again, we'll just go right to what's the grid cap. And 5 ohms. So let me document that. I'm just creating me a little scratch point here on the bottom as well. So and I'll call this B. And point C. Let me get the LCR meter between these points. Again, this ground connection and the grid cap, and let's see again what the inductance is. Okay, 212 microhenries, 212. So let me document that. And you can see when I had this in circuit, I read 216. So I think my second time I must have got my connection points correct. Let's see if we can figure out this part of the coil. This is still somewhat of a mystery, and I think I had asked others what the heck this means. You guys are watching. Is this the gimmick by chance? What does this symbol right here represent? Okay, I'm going to go ahead and get the meter hooked back up here. What I'm going to do is leave my meter connected here, one lead to what would go to the grid cap of the type 58 connection right here. And again, let's see what we've got going on. You can see when I read it before to ground, I read 3.78 ohms and 143 microhenries. So let me double check here and see if we can figure out what segment of the coil is shown, is indicated here. Okay, a couple things we can rule out. Again, this is the primary connection. We know it's not it. This was our ground connection here, so it shouldn't be that. We're attached here to the grid. So, to me, it appears it would be the lead going over to the gimmick, or again, what I consider to be a gimmick, unless this was soldered up at one time and the solder connection just broke loose between the two coils. Let me strip this back just a bit, or let me just do this, see if we've got a good connection point here. And that kind of makes sense to me. 1.3 ohms. And you would expect the DC resistance to be lower, as indicated by the drawing on the schematic itself. If it's accurate, just single winding or fewer windings is indicated here versus here. So let me hook that up again and just document the results. Okay, 1.3 ohms. I'll document that, and then let's check the inductance as well between these 2 points. Alright, what I'm showing again is showing 1.39 ohms, and I read 1.3 on the meter, and it's showing the inductance right at 31 microhenries. So let me notate that. So I think we've got things figured out here on the coil. I'll draw a better representation here for my future documentation. and show that a bit later on. Let me set this aside and see if I can get the second coil out safely, and or disconnect the other connectivity points and make these same measurements. Real quick here, one more try on the primary inductance. You can see about 13.65. So we'll just call it 14 microhenries. Alright, I'm going to try to just measure this again with it in the circuit, and let's see what happens. Really just want to document the inductance anyway, to be just mindful of what that is. And you can see I've already got this marked up, so this may be accurate, but again, you can see the coil connection here for the second coil is just a little different. So here's the primary side, and you can see it's a direct connection back to the type 58 tube, which is the plate here. So let me get the meter over here. We'll look at DC resistance again first, and measure from the plate of the type 58 tube back down to, we'll use R3, and let's just see what we have, because you can see the points here. So we'll measure from here back to here, and you can see my original documentation, 9.2 ohms. Okay, pins number 1, pins number 2, and you can see the red lead here, again because there's B plus on this as well that runs through the coils right here. And now let me see if I can identify where R3 was again. Alright, R3 resides here, so my connection point that I want to make should be right here. And it looks like 9.2 ohms from my angle. And that's what I read before. Let's put the LCR meter in and see if we can document the inductance, if it will tell us so. Again, I may have to pull this thing out of circuit to do so. But again, I'm really more interested in the secondary inductance, to see how close these two coils are together for tracking using the tuning condenser. Of course, there's trimmers on the tuning condenser as well for each section here to do some fine tuning. Okay, I'll go ahead and document this. Again, you can see the 9.3, 9.4 ohms. This meter read about 9.2. And you can see my inductance here on the primary side, again, in circuit, right at 190 microhenries. Let me go ahead and notate that on the schematic. Alright, let's move along over here to the secondary side and look at it. Here's the secondary piece again, and seems to be a little simpler here, we'll see. But again, I'm going to go to the ground connection, which is here, and then we'll measure back over to the grid cap of the 57 tube. Sometimes the schematic themselves are confusing, and the reason why, they don't tie back to the physical property or layout. so it can twist your mind just a bit at times or be confusing. So just a moment ago I said I'll check the secondary winding. We'll go from ground. That's simple enough. That's located here. But where should the secondary winding be? Okay, well I said I'll just go over to the grid cap of the 57 tube. So that sounds simple enough. Let me flip this over. Here's the 57 tube, and you can see there's no grid cap. So it resides on the tuning condenser here, which is located here. So what's the connection point from here back to the coil? And that's this connection point here. So again, if you're looking at the tuning condenser, I have continuity between this point and this point. And that's indicated on the schematic here, would be that tie-in point. Let me flip this back over. Let's see where this lead goes. That should be the secondary of the RF coil. And you can see it comes through the chassis right here and connects to this point. So let's see what we get here. Okay, 5.1 ohms. See if I can get that lead to stay there. And that's what I documented. I had 5.2. So let me substitute the VOM here for the LCR, and let's go back and remeasure the inductance here and see if it's close to what I read before of around 206 microhenries. And if you guys can see that, that's what we've got, 205. So I read, what did I say, 206 before? No, 205.6. So it's a perfect match to what I read yesterday. So let me document that real quick. And again, you can see the DC resistance here as well, 5.16 ohms. Alright, one more segment here to document, and it will be this section right here. So again, I think this is the gimmick, and there's no tie-in points between here other than the gimmick capacitance. So again, my connection point, we've identified this location being right here. So let's read from here back over to my gimmick wire right here. See what the DC resistance is between those points, as well as the inductance, and notate that. Okay, again, this is not stripped back, but the connection point on the coil is right here. So let me see if I can shift this down and still keep everything in view. It's right here on the side. Let me see if I can get my meter. Okay, I think it's attached there. And then I said I would just want to read back to here, which is my secondary winding. And again, that makes sense. A lower DC resistance because less wire. So 1.2, 1.3 ohms. Let me document that as well. Let's substitute the LCR meter now between these 2 points and see what we read. There we have it again, the DC resistance 1.40 and the inductance 31.6 microhenries, 31.6. Okay, I'm glad I didn't have to pull this one out of the bottom here to make those measurements. So just to recap again, we measured this segment of the coil. Again, anyone wants to chime in on what this slanted error means, that would be great, educational for me. I'll go ahead and tie in the wire and twist them around to create the gimmick the way I found it between the two coils. And again, I think that just has to do with your high-end performance or maybe oscillation. And if the radio does play, for giggles, what I may do is remove the gimmick, and we'll just see what difference, if it's notable on performance, that we can notate. With the coils documented, let's go ahead and move along. I think I'll go ahead and get the transformer in next, and get the B+ supply settled down, and leave the speaker tie-in points for last. By the way, after I remount the coil,